What can we do to make the bike better?
Let's really put our heart and soul into every one of these racing bikes.
How can we retain that same really nice ride quality that the F-Series bike has, but make it lighter and stiffer at the same time? So it's like, we want it all.
The current version of the F1 is really dialed. It's stiff and it's light and it rides really well. But it was just similar to the DA, it was just time to move on.
We still use the same geometry that I created back in 1990. It's still the F1 geometry, still the same.
All of the advantages and all the new materials that we've used, that we've developed over the years, have been incorporated on the F1 through 2010. The consumer sees the same frame mold, but you cut that bike in half, it's a totally, inside it's a totally different bike.
A new carbon material, we have a new resin, we have new layup, it's completely new bladder technology. The bike is basically built completely different than the old bike was.
It uses the dynamic monocoque construction, the fact that the inside-out technology is there, so the F1 also has the internal molds that allow for a perfect surface finish inside, allow for zero waste inside the frame. There's no extra filler, there's no extra materials inside. They're needed because of the molding process. The bladders take care of that.
Removing all that extra material that would be those heavy resin-rich voided areas in the bottom bracket, head tube, seat tube area are all gone now. Now it's uniform wall thicknesses throughout the frame.
And basically what the result was, we ended up with a frame that's about 100 grams lighter than the old F1, and amazingly enough, 35% stiffer. So we're hitting stiffness to weight numbers in the 200 range now with this new F1, which is pretty significant.
Jeff, our senior engineer, came up with some ideas. He started brainstorming and we started talking about how he could build a better F1, and sure enough, he built a better fork. He built a 1.5-inch bearing, BB30, super stiff, super lightweight.
And with these new materials we have access to, the nanotechnology, the inside-out technology, the new molding processes, the new materials, with all this new stuff, what would we do? A small frame can get really harsh really quick if you overbuild it. A big frame can get soft and too flexible really quick if you try to build it too light.
In some ways, you look at the bike and a lot of the tubes look larger, and that's the case for the chainstay, the down tube. But in other areas, we've actually made the tube smaller. That's because we can get the same stiffness out of using less material, using some of this new advanced carbon fiber materials.
So just like how the tube shapes change, the layups change. So every frame, every size has a completely different layup schedule. So again, mixing those materials, how much high modulus material you use, how much of the lower modulus material you use for the strength is different between every frame. So we try to make a bike that rides perfect for that smaller rider who's lightweight, and a frame that rides perfect for that larger rider who's a stronger, more powerful rider.
The new F1 was developed in harmony with some of the new components available for us for 2011. So we've got the Shimano Dura-Ace Di2 system on the top of the line bike, and that system is now completely integrated into the frame, so the wires and all the electronics are going to run inside.
BB30 is a bottom bracket spec or a crank spec, and it's a larger bearing kind of integrated into the frame.
Here's an example of an aluminum BB30 shell that a lot of people are using. You can see how much oversized it is, and it doesn't use threads, it uses a press-in bearing. Well, the idea of a press-in bearing is great because you no longer need the threads. However, this larger shell out of aluminum is significantly heavier than the old threaded one. This is about 60 grams. So what we've done is actually gone back and remade this part using carbon. So instead of using an aluminum BB30 in our bike, we now use a carbon BB30 shell. So it allows the bearings to press in, and remarkably ends up being only about 30 grams. So not only is it a considerable weight savings over an aluminum BB30, but it's a considerable weight savings over the threaded bottom bracket that we've been using in the past. One of the requirements was that we make a bike that is equally good for both Di2 and for mechanical cable guides. In the past, people have had it either one way or the other. It's either been a mechanical frame, where you have to have external wiring for the Di2. It's not as clean, not as refined. Or you've had it a Di2 bike where you have no cable guides. Well, we came up with a system that works equally well with both. There's a small plate that mounts in a down tube. This would be for a mechanical type system. But simply removing this plate, exposes an opening for the cables. So when you do so, you can see the threaded hole and then also the locating pin. The locating pin is where the Di2 wire would go in, and all the wiring is internal. The bottom bracket cable guide comes off and exposes a hole. So the same hole that holds the mechanical cable guide serves two purposes. In this case, for Di2, it would be to put the internal wiring into the frame. So instead of using holes inside the BB shell that take away from the structure of the frame, we use the hole that needs to be there anyhow for the mechanical system to run the Di2 internal wires. Same thing happens in the rear of the bike. The cable guides are removed, and it allows us to use internal routing right by the rear derailleur. So what does that mean? I mean, it really just comes down to peace of mind. When you buy the new Felt F1, who knows what the market's going to do as far as components. Maybe this year you want mechanical, but maybe next year you want Di2 from Shimano. So you're not stuck with a frame that can no longer be adapted. You can simply make this frame just as good Di2 as you can mechanical, just like the BB30 system. Not only does it save weight and help us with the structure of the frame, but it's also fairly universal now in the fact that they make universal adapters that can make BB30 fit anything. So you can use Shimano cranks, you can use SRAM cranks, you can use any crank you want in this bike and not be limited by some specific special BB shell that only fits one crank or something that comes only with the bike.
Additionally, with the integration of Di2, we've added the BB30 compatibility, the new tapered steer tube, which allows us to make the wall thickness of the crown, the steer tube much thinner and more continuous in terms of the fibers and the shape.
Using, again, the fiber to optimize the shape. We've gone with a 1.5 lower bearing and an 1.8" standard upper bearing. And what that allows us to do is make a fork that has a very smooth transition between the fork blades and the steer tube. As you know, in a traditional fork, you have a 1.8" steer tube that would come down and have a very sharp square corner at the bottom of the fork. Well, that's a stress riser area because a lot of the load of the bike is going through there. So you really have to overbuild that part of the steer tube very thick. Anytime you overbuild the carbon, it takes the life out of it and takes some of the feel out of that. So what you can do is if you look at this fork, you can see it's basically made in two different pieces. This upper part you see is actually an aluminum crown that is co-molded onto the fork afterward. If I were to take this crown off, you would see that the shape of this fork comes down and blends very smoothly into the steer tube. There's no step between the fork blade and the steer tube, so there's no stress riser there. That also lets the fiber stay very flat and very straight, which gives the fork a lot of stiffness. If you remember, carbon fiber works best in tension, so you can imagine having straight fibers coming across the steer tube and down to the fork blades. On both sides will make a fork that's very stiff side to side, so when you're out of the saddle sprinting and climbing, that fork is very solid.
It's got full carbon contact points, such as the dropouts, the bottom bracket shell. The seat tube doesn't use an aluminum shim to be machined to size for the 27.2 seat post. So a lot of those details that we've been able to work out in full composite allow us to make them much lighter.
Not only do we design the frame and forks, but we bring the parts in and we ride them here. We test them with our athletes, and we make sure that the bikes are going to handle the way the bikes need to handle for that category.
The 2011 F1 will also use Shimano Di2. The wheel set will come from Mavic. They have a new wheel and tire combination that we're using. It uses their Cosmic Carbon Ultimate wheel, the same wheel that you're finding underneath almost all the professional Mavic-sponsored riders. Super light, aerodynamic, extremely rigid.
If you look at the current F1, by all accounts, it's an amazing bike. I mean, somebody might say, well, how do we make this thing better? But it goes back to, you're always just striving for greatness. And in our case, I think you're always striving to be exceptional.
You know what, let's not build a Me Too product. Let's really put our heart and soul into every one of these racing bikes, especially that somebody's going to put their legs over and ride.